Good afternoon, class. Can we stand for a prayer? Can we lead the prayer? Maranyan. In the Father, the Son, and the Holy Spirit. Amen. Our Father in heaven, hallowed be your name. Your kingdom come, your will be done on earth as it is in heaven. Give us this day our daily bread and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen. And the Father, the Son, and the Holy Spirit. Amen. Okay? You may now take your seats, class. For your attendance, say present when your name is called. Ambi, Maranyan, Ranis. Yes, very good. All of you are present today. So before we proceed with our new lesson today, class, let us have a review of what was our topic last meeting. Okay, who can still remember what was our topic last meeting, class? Anyone? Okay, please stand if you want to answer. Very good. So our topic last meeting is all about organic compound. Now, when we say organic compound, class, what does it mean? Anyone? Any idea? Yes, correct. So when we say organic compound, it means that any large of chemical compounds in which one or more atoms of carbon are covalently to atoms of other elements, and most are commonly known as what we call oxygen or nitrogen. Okay, so what are the main types of organic compound, class? Anyone? Yes, very good. Those are the carbohydrates, lipids, proteins, and nucleotides. Very good. And these compounds are said to be organic because they contain both carbon and hydrogen. Okay. So any questions with regards to our topic last meeting? Any questions, class? Okay, there's none. So, at this juncture, I have here some pictures and I want you to observe and analyze each picture's, class. I want you to observe each picture and analyze. Now, how about the first picture? What have you observed? Very good. How about the second picture? Very good. So, based on the pictures, class, since there is a female weighing the substance or product, can you easily count each pieces? Or can you easily count each one by one? Yes, it's a no because there are many. Now, since there are many, also they are too small and that is a very difficult to count. Now, how can we measure or count the quantity of the substance, class? Any idea? Of course, correct. By using the measurement or scale. Very good. So, we need to weigh the substance by using the scale. And the unit we use are either kilograms or grams. Now, what do you think is our topic this afternoon based on the pictures that I have shown to you, class? Anyone? Yes, very good. It talks about quantifying substance. So, for today, you are tasked to explain the concept of mole, calculate problems underlying conversion of mole concept, and state the importance of mole concept. Now, how can we quantify substance in the field of chemistry, class? Any idea? how can we quantify the substance, class? Very good. So, through the concept of mole. Now, when we say mole, what does it mean? What is your idea when we say mole? Very good. How about the others? An idea? Yes, exactly. So when we say mole, it is a fundamental counting unit in chemistry. Take note, class. When we say mole, it is a fundamental counting unit in chemistry. So, mole concept allows us to count these very small particles. And also, a mole is a very convenient unit to use. Why? Yes, very good. It's because of many numbers of particles that is present in a certain atom or molecules that is very difficult to count. That's why by counting those scale that or the pictures that I've shown to you, we need to use the concept of mole. Because take note, class, that mole is the fundamental counting unit in chemistry. Do you understand, class? Okay, very good. Now, how can you calculate the number of moles? Any idea? Anyone? Very good. How about the others? Very good. So, by using Avogadro's number. So take note, class, that Avogadro's number was coined by the Italian scientist, namely Amedeo Avogadro. So this is the Amedeo Avogadro, the one who invented the Avogadro's number. So the number of Avogadros is equal to an idea. What is this? Very good. So Avogadro's number is equal to 6.022 times 10 raised to the power of 23, or it is equivalent to 1 mole. Take note, class, that the Avogadro's number is 6.022 times 10 raised to the power of 23, which is equivalent to 1 mole. Do you understand, class, the Avogadro's number? Okay, so let us proceed. The mole of a certain element implies two things. First one, the atomic mass expressed in grams is different for each element. This mass is known as the molar mass of the element. And the second one is the Avogadro's number of atoms is the same for all elements. For example, take a look at the picture, class. Try to observe. What have you observed? Very good. So, these pictures is the example of the two implications. The 1 mole of carbon is equal to 12.01 grams, or equals to 6.022 times 10 raised to the power of 23 atoms. So, next, 1 mole of oxygen is equals to 16.00 grams, equals 6.022 times 10 raised to the power of 23 atoms. So, means to say that this first part, the 1 mole of carbon equals 12.01 grams, is the first implication, while the second part, which is equals to 6.022 times 10 raised to the power of 23 atoms, is said to be the second implication. Did you understand the example, class? Okay, very good. Questions with regards to this example, class? Okay, now let us proceed to the interconversion of mass, mole, and number of particles of an element. So, our first conversion is mole to mass. Now, what is the formula of this conversion, class? Any idea? Yes, very good. So, the formula is mole times grams over mole equals mass. Now, where can we find the first mole, class? Any idea? Very good. We can find the first mole based on the given in the problem. Now, how about the grams? Where can we find the grams, class? Okay, very good. We can find the grams in the atomic mass of the given element in the problem based on the periodic table. And how about our second mole, class? Yes, exactly. It is equivalent to 1 mole because it is constant. Okay, so let's try this example, class. Number 1. What is the mass of 3.00 mole of carbon? Now, our given here, what is unsay gipangita sa problem? Okay, very good. So, our given is the first mole, which is equals to 3.00 mole of carbon. And the grams of carbon, which is equal to 12.01 grams. And our second mole, which is equals to 1 mole. Means to say that this our given. Now, let's try to substitute our given problem to our formula. Okay, let us substitute, class. Okay, so 3.00 times 12.01 grams of carbon over mole is equals to, okay, so we need to times the value of mole, which is 3.00 times 12.01 grams of carbon, divide by 1. So, it is equals to 36.03 grams of carbon. So, again, the answer is 36.03 grams of carbon. So, this is the solution to our first problem. Okay, so, any questions, class? Okay, so let us now proceed to the second example. Number 2. What is the mass of 6.00 mole of nitrogen? Okay, what is our given, class? Okay, so, very good. The mole is equals 6.00 mole of nitrogen. And, of course, the gram of nitrogen is equals to 14. And our second mole here is 1 mole. So, this is our given to the second problem. Again, our mole is equals 6.00 mole of nitrogen, and the grams is 14.00 grams, and second mole is equal to 1 mole. Now, this given problem, we need to substitute this to our formula, which is the mole times grams over mole equals mass. Now, we need to substitute. Our first mole is 6.00 times 14.00 grams of nitrogen over 1 mole. So, we need to multiply the value of mole, which is 6.00, times the value of grams of nitrogen, which is 14, divided by 1 mole, which is, because it is constant, so the answer is equal to 84 grams of nitrogen. So this is our solution, class. The answer is 84 grams of nitrogen. So Any questions, class, with regards to our second solution? Okay, very good. So let us now proceed to another conversion of mole, which is what we call conversion of mass to mole. Now, do you have any idea what is the formula of this conversion, class? Yes, correct. So the formula is mass times mole over grams equals mole. Now, where can we find the mass, class? Any idea? Okay, very good. We can find the mass based on the given problem based on the given in the problem. Now, how about our first mole? Where can we find? Okay, correct. Our mole here is 1 mole because it is constant. Now, how about our grams? Where can we find the grams, class? Any idea? Very good. So, we can find the grams in the atomic mass of the given element in the problem based on the periodic table. So, let's try this problem, class. Number 1. How many moles are present in 25.6 grams of carbon? Okay, so our given is in 1. Okay, very good. So the mass is equals to 25.6 grams of carbon. And our mole is equal to 1 mole. And of course, the grams of carbon is equals to 12.01 grams. So this is our given in the problem. Okay, so what we're going to do is we need to substitute this given problem in our formula. Okay, so our formula here is mass times mole over grams equals mole. So we need to substitute the given to the formula. So it should be like this. 25 times 0.6 grams times 1 mole over 12.01 grams equals 2.13 mole of carbon. So it looks like this, our solution in our first problem. So again, the answer is 2.13 mole of carbon. So any questions, class, with regards to this solution? Anyone? Okay, there's none. So let us proceed to the second problem. Number 2. How many moles are present in grams of 30.00 grams of magnesium? Now, what is our given here? Anyone, class? An idea? Yes, very good. So, our mass is equal to 30.00 grams of magnesium. And our mole here is 1 mole. And the grams of magnesium is equals 24.3.05 grams. Again, the grams of magnesium is equal to 24.305 grams. So, this is our given problem in our problem number 2. And of course, we need to substitute this given problem in our formula, which is the mass times mole over grams equals mole. So, we need to substitute now. So, our mass is 30.00 grams times 1 mole over the value of magnesium or the grams of magnesium, which is 24.305 grams. Now, what we're gonna do is we need to multiply the mass times mole and then divide it by the grams. So, the answer would be 1.23 mole of magnesium. So, this is our solution in our problem number 2. Okay, so any questions? Okay, since there's none, so let us proceed to another conversion of mole, which is the number of particles to mass. So this is our third conversion. Now, what is your idea or what is the formula of this conversion, class? Any idea? Any idea, class? Yes, you are correct. So the formula is number of particles times mole over 6.022 times 10 raised to the power of 23 times grams over mole equals mass. So this is our formula of this conversion. Now, where can we find this number of particles, class? Very good. You can find this based on the given in the problem. Now, how about our first mole? Yes, very good. We can find it. It's because it is equals to 1 mole because it's already constant. Now, how about the grams? Where can we find the grams? Correct. We can find the grams in the atomic mass of the given element in the problem based on the periodic table. Okay, so this is the formula of the conversion of number of particles to mass. Now, let's try this problem, class. Number 1. What is the mass of 1.806 times 10 raised to the power of 24 atoms of carbon? Okay, so what is the given of this problem, class? Anyone? Yes, very good. So, number of particles is equals 1.806 times 10 raised to the power of 24 atoms of carbon. And our mole here is 1 mole. And of course, the Avogadro's number is equals 6.022 times 10 raised to the power of 23. And our grams is the atomic mass of the given element in the problem based on the periodic table. So of course, the value or the mass, atomic mass of the carbon, which is 12.01 grams. Okay, so we need to substitute our given problem to our formula. So our solution will be look like this. So number of particles is 1.806 times 10 raised to the power of 24 atoms times 1 mole over the number of Avogadros, which is 6.022 times 10 raised to the power of 23 atoms times the grams of carbon, which is 12.01 grams over 1 mole. So we need to multiply the number of particles times mole over Avogadro's number times the grams over 1 mole. So our answer will be 36.03 grams. So again, this is our answer, which is 36.03 grams. So take note, class, that to cancel the exponent, we need to convert one of them. So for example, based on the problem, the 1.806 times 10 raised to the power of 24, which is the number of particles, it will become 1.806 times 10 raised to the power of 23. It is because we need to move the decimal point to the left, means addition. So, ang exponent maadan. So, if we move to the right side, the exponent will be subtracted. So, based on our first solution class, the number of particles, the exponent is 24. That's why, asa mo ta mo-move in order nga mahimo sa diyang 23. Okay, correct. We need to move on the right side so that it would become 1.806 times 10 raised to the power of 23. It's because we need to change the exponential that is equivalent to the amount of the Avogadro's number so that we can cancel. Okay. In a questions class with regards to our first solution, any questions? Do you understand? Okay, very good. So, another example, number 2. What is the mass of 1.106 times 10 raised to the power of 24 atoms of oxygen? Now, what is our given here? Very good. So, the number of particles is equals 1.106 times 10 raised to the power of 24. And our mole is 1 mole of oxygen. And our Avogadro's number, of course, it is 6.022 times 10 raised to the power of 23. And our grams, which is the atomic mass of oxygen, which is 16 grams. Now, what we're going to do is we need to substitute our given problem to our formula. So for our solution, here the number of particles, which is 1.106 times 10 raised to the power of 24 atoms, times 1 mole over the number of Avogadros, which is 6.022 times 10 raised to the power of 23 atoms, times the grams of oxygen, which is 16 grams over 1 mole. So we need to multiply and then divide. So our answer will be 29.39 grams. So our solution would be like this. So again, you have to take note, class, that to cancel the exponent, you need to convert one of them. For example, based on the given, the 1.106 times 10 raised to the power of 24 will become 1.806 times 10 raised to the power raised to the power of 23. It's because we need to move the decimal point to the left, means to say it is addition. So we need to add the exponential. And to move to the right side, the exponent would be subtracted. So in our case today, in our second problem, we need to move on the right side so that the exponent of 24 will become 23, so that we can cancel our number of particles and the amount of the Avogadro's number, so that we can proceed in solving this solution. Okay, so any questions with regards to our solution in our second problem, class? Okay, so do you understand? Okay, very good. So this time, let us proceed to another conversion of mole, which is mass to number of particles. Now, what is the formula to this conversion, class? Okay? So, very good. The formula will be mass times mole over grams times 6.00. Okay, so this time, let us proceed to another conversion of mole, which is mass to number of particles. Now, what is the formula of this conversion, class? Any idea? Yes, very good. So the formula is mass times mole over grams times 6.022 times 10 raised to the power of 23 over mole, which is equals number of particles. So again, the formula, class, will be mass times mole over grams times 6.022 times 10 raised to the power of 23 over mole equals number of particles. Now, what is our given here, class? I mean, where can we find the mass? Correct, based on the given in the problem. Now, how about our first mole? Correct, it is constant. Now, how about our grams? Very good. We can find in the atomic mass of the given element in a problem based on the periodic table. Okay, so let us try this first problem, class. Now, number 1. How many individual atoms are present in 12.5 grams of oxygen? So, what is our given here, class? The given is, correct, the mass, which is 12.5 grams. And our mole is 1 mole. And of course, the Avogadro's number is 6.022 times 10 raised to the power of 23. And our grams, which is the grams of oxygen, which is 16 grams. Now, what we're going to do here is we need to substitute the given problem in our formula. Okay, so anyone who can share his idea, his or her idea, and write it on the board. Okay, very good. Your answer is correct. So the solution would be like this. 12.5 grams times mole over 16.00 grams times 6.022 times 10 raised to the power of 23 over mole, which is equals 0.48 times 10 raised to the power of 23 atom. So again, our solution will be like this, and the answer is 0.48 times 10 raised to the power of 23 atom. Okay, so any questions with regards to this conversion, class? Okay, do you understand? Okay, very good. Okay, now, again, what is mole, class? Very good. Now, what are the different conversion of mole? Yes, correct. So, any questions, class, with regards to our discussion today? Okay, since there's none, let us apply some of your knowledge, class. So, for our first activity, you need to solve the given problem, and then you have to show your solution in the paper. Okay, so this is our first activity, which is 1 to 6 numbers. Okay, so any paper will do, and then if you're done, you have to pass your paper here in front. Okay, so everybody is done? Okay, that's great. So pass your papers here in front. And for your quiz today, you have to convert the following problems. So this will be numbers 1 to 5. And then, of course, you have to show again your solutions at the back of your paper. Okay, are we clear? Okay, so if you're done, again, you can pass your papers here in front. Okay, anyone is done? Anybody is done? Okay, that's great. So let us proceed to another. Okay, so this time, since all of you are done with our quizzes today, since all of you are done with our quiz today, so this time, I want to say thank you for the cooperation and participation, class, and then let's end for today. Let's end for today, and then goodbye, class, and have a wonderful day. Thank you.